All right, today we're talking about graphing inequalities on the coordinate plane. So if I'm given this inequality, x is less than or equal to 3, on a number line, here's how it's going to look. I'm going to start where? Where do I start? Sarkis.
3.
Okay, what kind of line is it?
It's a line going to the left.
Going to the left, and what? How does my starting point look?
Closed circle.
A closed solid circle. Okay, I'm going to start at 3. I'm moving it to the left, and it's a solid circle. That means it's any number to the left of 3, and including 3. When I graph this on a coordinate plane, we have to temporarily, when we're graphing inequalities, go back to our linear equations. Remember, on the coordinate plane, we were dealing with linear equations. Or how did we graph equations with one variable? That look like this, x equals 3. What did we do to graph those kinds of equations? Sarkis.
The x is set, so all you need to do is find what you can just pick y. So
Okay, so what did I set up to organize my data?
you put the chart and you put x 3 3 3 and then y could be anything.
We put x and y, and I used, what's this called? A T-chart. What else? A table, and I organized my information. You said the x is set. That means x is a constant, and it's always going to be 3. The next thing he said is I choose my y's. I pick any 3, he said. So I'm going to go with 0, 1, and 2. And I'm going to plot those points. 3 across, 0 up. 3 across, 1 up. 3 across, 2 up. And we're seeing a pattern. Now this is what we call a boundary line. It is creating a boundary line. So what I'm going to do with that boundary line is now I'm going to draw a line through it. I'm drawing a line through it, okay? And, okay, so I've now drawn a boundary line. And basically, the type of boundary line I am going to draw is going to depend on this symbol. And if it is less than or equal to, or greater than or equal to show that it includes all these points on this line, I'm going to make it solid. If it were just less than or greater than, it would be dashed. It would be dashed, and then it would look something like this. Does that make sense?
Yes.
Okay, so when is it dashed? Jason?
Only when it's greater or less than, not equal to.
Okay, when is it solid, boundary line? When is it a solid, Rogelio?
Equal to.
When it's equal, it becomes solid. Okay? Now, we have to do, what this is saying is x is less than or equal to this boundary line. So that's any point less than or equal to. I can choose any point. Which point do you want to choose? Give me a point. Which point do you want to choose? Sarkis.
-1.
-1 what? This is a coordinate plane. -1, comma.
1.
Okay, so that point is down 1, up 1. I'm going to substitute that in. Well, I really don't have to deal with the y because there's no y in this equation. So I'm going to say -1, is that less than or equal to 3? Is that a true statement? then if that's a true statement, then that's the side of the line that I end up shading. If he had chosen, let's say he chose this point. That is, x is 1, 2, 3, 4. X is 4, comma, 0. Well, we really don't have to deal with the 0, but the original equation was x is less than or equal to 3. Is 4 less than or equal to 3?
No.
Since this is not a point, since it doesn't work, I shade the other side. Do you understand the idea of a test point? It doesn't matter what point you work at, what point you choose. Whatever point you choose, let's say I pick this. If this turns out to be true, that side you shade. If this turns out to be false, you don't shade that side and you shade the other side. Okay, Oscar.
I don't get how you substituted for the x. Like, how'd you substitute -1 and 4? Yeah.
We picked a point.
So you just pick a random point.
Right. We picked this point, any point. Now this point over here was 4, 0. But there's no y, so I got rid of that. And I substituted the 4 in for the x in the equation.
And if the system is like...
If it turns out to be a true statement,
you shade that section?
yes.
And if it's not true, you shade the other one?
The other one, exactly. Yes.
What do you mean by you shade the other one? You ended up shading.
Since this is not this point right here, where the x is, since that's not true, that makes this not a true statement. I don't shade this black side. That's not the side to shade because it makes it a false statement. I say shade the other side.
And if it is a true statement?
Then I shade that side. So there are no wrong points to pick. Yes.
So, wait, how do you, I didn't understand how you graphed it though. Like
Well, remember back when we were in chapter 7, we graphed equations with one variable. When you have one variable, you set all that the constant. Because x is equal to 3, x is always 3. And I choose my y's. And then I plot those points. And I looked for the boundary line. Once I made that table, I plotted this point, and this point. And that showed me I got this. So that's clearly the line. Okay? Yes?
just clarifying, do you shade the side that's true? Or
True.
Do you shade
That's true. Okay, there's another way to check for boundary, hold on one second, to boundary lines. Okay, and the other way is, look, I just make sense of this. Okay, so notice it says x is less than, it says x is less than 3 or equal to 3. So that's this point right here. I look at the intercept. Okay, Lucy, do you mind? Okay, so I'm looking at the intercept. The numbers that are less than 3 are all right here. 2, 1, 0, -1. Do you see that? And so I would know that. I look at the intercept. Let's look at another one. Okay, y is greater than -2. So how do we, temporarily, we make it an equation. When I make it the equation, how do I figure out my points? Or actually, let's first look at it on the number line. On the number line, okay, on the number line, it looks like this. Start at the 0, at the -2. Is this an open or a solid circle?
Open.
And which direction is it going in?
To the right.
To the right. Okay, next one. On the coordinate plane. Okay. How do I graph y is greater than -2? Okay, Sarkis?
You graph the t-chart again.
Okay.
And this time instead of putting x's, you can put x as anything and look for y.
Okay, so I set my t-chart, x, y. This time, we're setting y as -2, because y is the constant. And my x is anything. 0, -2, 0 across, down 2, 1 across, down 2, 2 across, down 2. Oh, you're right, you're right. Sorry. 0 across, 1 across, down 2. Sorry. 2 across, then down 2. Okay, boundary line. Can we see where it's going? Is it a solid or a dashed line? It's going to be dashed this time. Now again, the one way that I look at it is I look at my y-intercept. I read from the y. Numbers greater than -2 on the y-axis. What are the numbers greater than -2 on the y-axis? Above or below that line?
Above.
Numbers greater than -2. Here's -2. Here's -2. Where are the numbers on the y-axis that are greater than -2? Piper?
Above.
Above. So that's the area I'm going to shade. I can do the test point method. Okay, I can take a test point. What test point do you guys want to take? David? 2, 1. Let's see. 2, 1. The original equation is inequality is y is greater than -2. Okay, now I'm going to substitute in y. We said our y is 1. Should this be a true statement? What do you think?
Yes.
Why?
Because 1 is greater than -2.
But why should this be a true statement based on the picture?
Because -2 is less than 1.
You're talking about the inequality. I'm asking about the picture. Why should this be true?
It's on the shaded side.
It's on the shaded side, yes. It's a true statement here. And it's also in the shaded spot. Now again, all the numbers greater than -2 on the y-axis are all up here. So that was the area I shaded. 2 ways to identify shading. Can I erase? Yes.
So I got the part where you shaded. The one thing I can't get is how you. I understand that it's correct if it's on the shaded part, but wait.
What if I had chosen this point right here?
Then you have to shade the other side.
This should work out false. If that works out false, then I shade the other side of the line. Look. Pretend none of the shading existed. Okay, I'm choosing this now. Whoops. I'm choosing now this. Okay, so now pretend that this is, let's choose this point right here. Okay, that point is 1, 2, -2, comma, 1, 2, down 1, 2, 3, 4. Negative 4. Okay? The equation is, so I'm using negative 2, comma, negative 4. The inequality is y is greater than negative 2. Okay? So which one is not even going to is not even part of this? Do I not need to use? Honey, what does this represent? Negative 4? It represents a y. And what does the negative 2 represent? And what is not included in this equation? Inequality. So this is the one that's not even used. Negative 4. Negative 4, is that greater than negative 2? Is that a true statement? So this is not the area down here to shade. That means I have to shade this other part. Okay? If it's proven false. Okay, so now we do slope-intercept. I've got to move on. I'll take your question a little bit. What are the important parts? Pretend temporarily this is an equation. What do I need to graph the different parts? Yes?
You need the slope and the y-intercept.
Okay, I want to hear from somebody else. So slope and y-intercept. What am I pointing out, writing on my paper so I get credit from my teacher? Don't do things in your head. Ben, what do I have to pull out?
So the slope is 2/3.
Good.
And the y-intercept is -1.
Okay. And now? And now? Where would my starting point be for graphing?
You plot a point on -1 for the y-intercept.
Okay, Luke, what am I doing next?
You're rising 2 and running 1 or 3.
3. Rise 2, run 3. I can do -2, -3. -2, -3. Okay. Oh. Is this going to be solid or dashed? Rogelio. Why?
Because it's less than or greater.
Less than or equal to. Okay, now the shading. We can pick a point or look right here. This really here's my shortcut method. And both methods work. Okay. Y is less than. Go to the y-axis. Your point on the y-axis is right here. Which numbers are less than? Notice where it says whatever's touching the y. Y is less than or equal to. Which area is less than that -1? Which area is less than, above or below that point? Yes. Below. I didn't even do a test point. I'm shading that area. I looked at this. What is less than on the y-axis? What's the other way I could figure out the boundary line? What? What'd you say? I hear somebody, test point. So let's choose 0, 0. Should this answer be a solution?
No.
So y equals, y is less than or equal to 2/3 x minus 1. 0 is less than or equal to 2/3 times 0 minus 1. Is 0 less than or equal to -1? Is 0 less than or equal to -1? No. So this point right here should not be shaded. I have to shade the other side right here. 2 ways to identify the shaded area. So here's the basic rule. Please write this down. This is assuming it's touching the y. To shade up, touching the y should be greater than or equal to if it's solid. Should be a greater than or equal to if it's solid. To shade down, the less than or equal to should be touching the y if it's solid. Right? And it would be solid. A dashed touching the y would shade up if it's greater than. A dashed shading down would be less than touching the y. Questions? Questions? All right, so now the important part here is to identify your m and your b. M is -1, b is 3. Starting at positive 3. And rising -1, run 1. -1, run 1. -1, run 1. Okay? Doing that also, doing +1, -1. Rising +1, running -1. Now, will this line be solid or dashed, Gabriella? Dashed. Now, will I be shading above or below the y-intercept? Why? I heard somebody say you shade above.
Shade below. Shade below the way. No, the sign is on the bottom. They're supposed to shade above. It's above.
Let's look here. I'm having a hard time drawing on it. Shh. Come on. So I'm having a hard point drawing on here. I'm looking at the... Sadat said, shade above that point. Why?
Because y is greater than it.
Well, y is any value greater than that. So that was our shortcut. We can also do the test point. Any number greater than that. And so we are going to shade above is what he said. Yes. The y-intercept is where I use, right here. Where the line crosses the y-axis, that's called the y-intercept. So the shortcut, so you don't have to use a test point every time, is y is greater than. Notice greater than here. Because I'm really looking for this here. Y greater than +3 should be the area of shading. If it had said less than, I would have shaded down in here, below that y-intercept. Okay, now, the one thing to remember, is you cannot do this until you get it into slope-intercept form. What does that mean? Yes.
Y equals mx plus b.
You've got to get the y alone. So what do we do to get the y alone here? Luke? Subtract 4x from both sides. Next step. Yep.
Oh, divide all terms by 5.
Divide all terms by 5. I'm left with, Sydney?
Y is greater than or equal to -4/5x plus 2.
Plus 2. And then we start the process all over. Okay, questions? All right.